Lesson 1.3, Measuring Inflation Rates. Inflation is defined as the percentage change in the price levels over a period of time. The time could be monthly, quarterly, or yearly. The equation for percentage change, not just percentage change in the price level, and we would use the symbol, the triangle, or delta to stand for change, is defined as the following. The percentage change of any variable is simply the new value minus the old value divided by the old value times 100. Whatever this number turns out to be, that's the percentage change. If we put this into the context of inflation as being percentage change in the price level, this would simply look like inflation rate will be equal to the price level in the year 2007, which is the new value, minus the price level in the old year, which is 2006, divided by my starting point, which is the price level of 2006, times 100. Whatever this percentage turns out to be, we call that the inflation rate. How do we measure the price level? There are at least two methods of measuring the general price level. Method 1 is the GDP deflator. GDP deflator measurement of price level is actually very similar to the real GDP and nominal GDP concepts that we talked about before. So let's carry on with the example from the previous lesson. We produced only two goods in 2006, food and clothing. And the quantities, remember from before, were equal to 10 units and 10 units. And the price per unit was $5 for food and $20 for clothing. For the year 2007, the quantities were 11 and 11, and the price per unit was 5.5 and 22, respectively. Let's suppose we also gathered the information for the year 2008. Quantity and price. The quantities, let's suppose they are 12 and 12. And the prices, suppose they are 6 and 24. Nominal GDP, we can calculate for each year. Very much like the previous lesson. For the year 2006, we calculated this already as being 10 times 5 plus the 10 times the 20. That would be 250. And 2007, we did this as well. That would be 11 times 5.5 plus 11 times 22. We found this before to be 302.5. For 2008, suppose we have the information already, and we can do the same thing. That would be 12 times 6 plus 12 times the 24. This would give us a total of 360. So that would be the different values of nominal GDPs across the 3 years. Remember that we can also calculate real GDP from the previous lesson. But with real GDP, I need to find a base year. So let's suppose I don't have to choose 2006 as the base year. But remember before we had this as being the base year. So let's carry on with this. 2006 is the base year. So I'm using 5 and 20 as the basis for my comparison and then evaluate the quantities 11 and 11 in 2007, 12 and 12 in 2008. Then what I will find will be the real GDP. So for 2006, nothing has changed. So real GDP is also 250. Real GDP for 2007, we did this before as well. We're just using $5 times 11 units plus $20 times 11 units. We found this before to be 275. And let's also do this for the year 2008. Real GDP would be just equal to 12 times the $5 plus 12 units times the $20. That's 20. So the real GDP in the year 2008 will be equal to 300. We talked about this before in the previous lesson. How can we use what we already know in order to find the GDP deflator? Let's see. GDP deflator is simply equal to the nominal GDP of the year, in this case 2006, divided by the real GDP of 2006 times 100. Nominal divided by the real, both of the values belong to the same year. And very simply, this would be just 250 divided by 250 times 100. That would give us 1 times 100. Therefore, the GDP deflator for the base year 2006 is 100. That is the basis for my comparison. Let's do the same thing for the year 2007. So nominal GDP 2007 divided by real GDP 2007 times 100. We know what the numbers are from above. Nominal GDP is 302.5. Real GDP is 275 times 100. This will turn out to be 110. Same thing for 2008. Nominal GDP 2008 divided by real GDP 2008 times 100. That would be 360 divided by 300 times 100. That will give us 120. So the GDP deflators for each of the years will be 100 for the year 2006, 110 for the year 2007, 120 for the year 2008. Overall, we can actually summarize this into a general equation. The general equation for GDP deflator is just the nominal GDP divided by the real GDP. Both of the values come from the same year. And one main thing to keep in mind is that because we're calculating the GDPs from different years, the quantities for each year can change. This is actually one of the main features of the GDP deflator, which is very different from method 2 in terms of the consumer price index. Now with the GDP deflators that we have just found, what are the inflation rates across the different years? If we look at from 2006 to 2007, this would be simply equal to 110 minus 100 divided by 100 times 100. So that would be a 10% inflation rate across these 2 years. And actually, once you get more comfortable with dealing with these numbers, any number compared to 100, the difference is by definition a percentage. Because overall, if you look at the equation, 110 minus 100 divided by 100 and then multiply by 100. What we can just do is forget about divided by 100 and multiply by 100. Just look at 110 versus 100. That gives us the 10% right away. This is also why we actually want the base year GDP deflator to be expressed as 100 because any number that we compare to it is automatically a percentage difference. We can also look at 2006 versus 2008. 2008, 120 minus 100 divided by 100, and once again this should be equal to just a difference of 120 versus 100. That would be a 20% difference. There's another pair that we can also compare. What about 2007 to 2008? Similar fashion, but now we're looking at 120 minus the old value is now the 110 from the year 2007 and divided by the 110 times 100. This would be equal to 10 divided by 110 times 100, and this would be approximately equal to 9.09% in inflation rate across just these 2 years, 2007 to 2008. A second method in which we can measure the general price level is the consumer price index. This we probably hear in the news quite often, that consumer price index has actually increased by, has actually driven inflation to rise by 2%. The consumer price index, as the name suggests, focuses on consumer goods, not everything that we actually produce. So consumer products. Why do we just look at consumer products? The justification is because consumption actually accounts for about 60% of GDP, which is the largest category under GDP. And also, consumer price index actually fixes the basket of goods and services that we actually tend to buy. The type of stuff we tend to buy, we assume that consumers do not change their behavior drastically from year to year. And the same thing with the quantities. We're not suddenly going to actually buy a lot more food or buy a lot less food. So what we focus on is we look at what consumers tend to buy. And over the 5 years or 10 years or so, we assume they buy the same amount, the same stuff, the same types. And then we look at how much more expensive or how much less expensive the same products would actually be across time. What type of products do we actually tend to buy? Statistics Canada carries out a consumer survey called the Survey of Household Spending. In the year 2005, the breakdown of our expenditure included the following. Number one expenditure, we spend the most of our money on shelter, around 28%. Followed by transportation, such as gas, cars. That account for about 19% of our expenditure. Then followed by food, which account for about 16% of our expenditure, and then followed by education, which you can probably identify with, for about 12%, and others. So consumer price index focuses on this type of expenditure and then look at, for the given quantities of different types of products that we actually would buy, how much more expensive or how much less expensive it is for us to buy them over time. How do we measure consumer price index? Let's look at a simple example, and also for the same 3 years. Suppose we produce and consume 3 products: food, phones, and movies. And during a typical year, we consume 10 units of food, 10 gift baskets of food, 1 phone, and we watch 2 movies. The prices will be $50 per gift basket, $100 for the phone, and $10 for each movie. So 2006, once again, let's suppose that is my basis for comparison, my base year. For consumer price index, we would say that for the next year, 2007. The quantities are the same, and the types of products that we actually would consume would also be the same. And we want to focus on how much more expensive or how much less expensive the same products are. Suppose in the following year, food turns out to be $55 per unit per gift basket. Phones have now gone up to 110, and movies have now gone up to 11. Same idea for the year 2008. Quantities and the types of products are the same. We want to focus on how much more expensive, how much less expensive they have become. Food, let's suppose, becomes $60 each gift basket. The phone now costs 120, and the movies each now cost $12. So according to the survey of households, these are the typical things that we tend to buy. These are the typical quantities that we tend to buy. And we want to trace how much more expensive, how much less affordable the same products are across different time periods. How do we get the consumer price index from here? Let's start off with the year 2006. And once again, let's suppose the base year, the basis for my comparison, because I actually picked the quantities and the types of products coming from 2006. So 2006 is my base year. I look at my expenditure in the year 2006. How much would this cost? 10 times 50 plus 1 times 100 plus 2 times $10. This would now cost me, for this particular consumption pattern, this will cost me $620 back in the year 2006. And also, let's do the same thing for 2007. So this would be 10 units, because I'm not changing the quantity, times 55, and 1 phone times 110, and 2 movies times $11. Altogether, the same products would now cost me $682 in the year 2007. I can do the same thing for 2008. You should try this as an exercise. What I will get towards the end is $744. That is my expenditure in the year 2008. How do I get my consumer price index from here? What I just need to do is consumer price index for the year 2006. I look at my expenditure for the year in question divided by the expenditure of my base year times 100. And because the year in question and the base year is the same for the year 2006, this would be just simply 620 divided by 620 times 100, 100 as the base year. Very similar to the GDP deflator. For CPI 2007, I'll just look at my expenditure in the year in question. That would be 682 divided by my expenditure from the base year. Base year was 620 multiplied by 100. Therefore, this would give me 110. Same idea for 2008. I would have 744 divided by 620 times 100. This would give me 120. And to find the inflation rates, we can do exactly the same thing as what we have done for the GDP deflator. 110 versus 100, so that's 10% inflation. 120 versus 100, 20% inflation. 120 versus 110, that's the 9.09% inflation from the previous page. So the way that we would actually derive the general price level would be quite different for the GDP deflator as well as for the consumer price index. After we actually get the general price level to find a percentage difference, and that would be the inflation rate, is identical regardless of what price level measurement we're using. One problem with consumer price index is that because for simplicity, based on consumer survey that we have done, we assume that across the 3 years 2006, 2007, 2008, the quantities that we're going to consume are not going to change. The quantities are fixed. And the quantities are fixed regardless of how much the prices have gone up by. By 10% or 20%, we're still going to actually go for 10 units of food, 2 movies. We're actually not going to cut back on any of the consumption. This in reality is maybe not 100% true, because when movies become more expensive, chances are we go from watching 2 movies to 1, or we try to actually find a cheaper substitute, go for DVDs or go for a walk in the park for entertainment. As a result, the consumer price index does not actually incorporate consumers being smart and try to find cheaper substitutes. And we say that the consumer price index tends to actually overestimate the bad effects of inflation because of the fact that when prices have actually gone up by 20%, I'm not going to actually increase my expenditure by 20% because I'm going to change the quantity. If we do not actually allow for the quantity to change, we say that the consumer price index has a substitution bias. Or an exaggeration of the rise in our expenditure. The substitution bias in size, studies have actually estimated it to be around 1.1% exaggeration in our expenditure. We have just looked at 2 ways of measuring inflation rates. Why does inflation matter? Actually, inflation for people who actually work, inflation, as long as it is stable and expected, it actually doesn't really affect us too much because very likely our nominal wages or paychecks are actually adjusted by the inflation rates. A lot of times when we hear unions and management, they actually try to reach a new collective agreement. Very likely the unions would actually ask for whatever the inflation rate turns out to be, we actually want exactly the same increase in the nominal wage and hopefully maybe a little bit more. So workers who actually work over time, inflation rates, if they're steady and they're expected, is not a big problem. But for those who have already retired, worked all their lives, and they have minimum income, so the adjustment is not very likely. Their living standard could easily be eroded by higher inflation rates. So for senior citizens who actually live on fixed income, the higher the inflation rates, because they don't actually have new wages coming in adjusted for inflation, their living standards could be adversely affected by higher inflation. Of course, the government actually sees that this could be the case. They try to index inflation into pension payments. But the problem is, most people would probably agree, you cannot really live on your pension coming from the government during your retirement. So high inflation rates tend to actually have adverse income distribution effects. Specifically, those who live on fixed income will be adversely affected. A second reason is inflation actually affects borrowers and lenders. And because as a country we tend to sometimes borrow money and sometimes we actually lend money to other countries, inflation actually tends to give us a bad reputation over time. Why is that the case? Let's start off with 2 people. Suppose you borrowed $100 from your friend or from a bank in the year 2006, and 2006 is the base year, so consumer price index is 100. You borrow this $100 and suppose you can buy 1 unit of the gift basket with different amounts of foods, clothing, and so forth inside the basket. and you promise to pay back the friend or the bank that you borrowed the money from a year later in 2007. And when you borrowed the money, you actually wrote and signed your name that you say you're going to actually pay back 5% in nominal interest rates. So I'm going to pay back $5 in interest payments. Is this a good deal or a bad deal? We actually do not know until we actually find out in the year 2007 what is the actual inflation rate turn out to be? What's the actual consumer price index will turn out to be? Suppose it turns out to be 115. In this case, the lender, your friend or your bank, does he gain or lose? Well, the $100 that you borrowed before actually bought you one gift basket. That's the purchasing power of the $100. Now with only 105 that your friend is going to get back. But the same basket actually costs 115, which means the lender gets back only 105. But for the same gift basket, it now actually costs 115. He or she will be $10 short. As a result, high inflation rate unexpected to be 15% in this case from 2006 to 2007, the lender would lose. Why would this be bad for reputation? Because we may actually be able to gain at the lender's expense this time. But if we do actually want to borrow in the future, chances are the lender or other lenders would now be asking for a much higher interest rate because of the fact that they were actually deceived the year before. So, high unexpected inflation rate will increase our future borrowing costs. It takes a long time to build a reputation, and it takes just one shot to actually destroy a reputation. In general, real interest rate is actually equal to the nominal interest rate minus the inflation rate. In this particular example, you borrowed $100 and you promised to pay back 105. So in money, you're promising to pay back nominal interest rate of 5%. But because the inflation rate has actually gone up from 100 consumer price index to 115, inflation rate is 15%. Remember that we said the lender is actually $10 short, $10 as a percentage of the 100. So what he's actually losing is approximately minus the 10% in purchasing power, buying power of the money because of high inflation rates. Nominal interest rates most likely will be a positive number. Real interest rates can be positive or negative depending on we actually ended up with a good deal or a bad deal. Now let us extend our analysis from two people to two countries. If a country is known to have high inflation, very likely foreigners who can potentially lend money to this country will not like it. This country, we say that, has a credibility issue, a reputation issue. Why do we observe inflation? Generally speaking, we tend to observe two types of inflation. One type being very low, stable, quite harmless, versus unusually high inflation rates. First type tends to be what Canada would have, measured in the terms of consumer price index. For the years 2000 to 2003, suppose these are the inflation rates. How do we find the inflation? For the year 2000 to 2001, that would be simply 102.5 versus 100, so that's 2.5% inflation. 2001 to 2002, I need to calculate 104.8, the new price level, minus 102.5, divided by the old 102.5 times 100. This will give me approximately 2.24% in terms of inflation. I can do one more from 2002 to 2003. Same fashion, 107.7 minus 104.8 divided by 104.8 times 100. This will turn out to be around 2.77% inflation rate. Quite stable, 2 point something percent year to year. What tends to actually cause this type of low inflation rates? Very simply because of wages. That a lot of times unions, workers, when they negotiate for wage increases in terms of nominal wages, in terms of in dollars, when they negotiate for wage increases, they tend to actually look back to inflation rates from previous years. If I have seen that over the past few years, each and every year, average inflation tends to be, say, 2%, 3%, I would actually start off negotiation asking for 2%, 3% increase in my wages, plus maybe a few more percentages in terms of increase in real income. But most of the time, I look at my past inflation rates, and then based on this information, then we ask for wage increases. And eventually, management and unions would agree to some terms and wages will increase. And the fact that wages will increase, this will increase the cost of the firms, production costs, labor costs. And when the firms have to produce more, have to actually pay more for their labor, what they would actually do is just they increase the prices and transfer them to the consumers. And once this will lead to higher prices, this would just lead to increase in inflation rates. More or less like a self-fulfilling expectation, I was believing that past inflation rates were actually 2%, 3%. I expected this year's inflation would be more or less the same. My action leads me to ask for wage increase to be about 2%, 3%. As a result of that, inflation, actual inflation, will also turn out to be what I have asked for in terms of the wage increase. So no surprises, and when workers look at past inflation rates, they also tend to believe what the future inflation rates will tend to be. A second type of inflation is much more harmful, and most of the time it is because of policy, or we tend to call this policy-induced inflation rates. If we look at Mexico back in the 1980s and their consumer price index, from here we can find the inflation rates from 1986 to 87. The inflation rate would be just, even though the numbers actually look a little strange, still the new value minus the old value divided by the old value times 100. This will actually give us an inflation rate across the 2 years to be 132% year to year. From 1987 to 88, we do the same thing. 29.3 minus 13.7 divided by 13.7 the old year times 100. This will also give us something quite outrageous, 114% inflation. Let's do the last pair. 1988 to 89. New value 35.2 minus the 29.3 divided by the old 29.3 times 100. This will give us something lower but still quite high inflation rates. What can explain such double-digit or triple-digit inflation rates? Very likely, most of the time, is actually because the central bank of this country, the country, in this case Mexico, with the central bank as the Bank of Mexico, very likely the central bank has actually printed money to spend. And the more money that you print, the supply of money starts to rise. The value of money starts to drop. And therefore, it actually takes twice as much the money, or 20% more of the money in order to buy pretty much the same products. Price levels will start to rise, or we say that the inflation rates are going to skyrocket. And once you actually have a country or a central bank who has a reputation of actually printing money to spend, foreigners or even their own people will start to lose confidence in the government, in the central bank, and it would actually take a long time for the central bank to rebuild its reputation.